Hello everyone. Usually, after the installation of the fire water supply and drainage system is completed, the fire protection equipment must undergo commissioning and acceptance testing. If the commissioning and acceptance test fails, the equipment must not be put into service. Commissioning and acceptance testing for the fire water supply system is a comprehensive inspection of the construction quality of the fire water supply and drainage project. And it is one of the essential tasks to be completed before handover. Now, let us begin this lesson. Before commencing the commissioning and acceptance test, prepare the necessary tools such as a steel tape measure, screwdrivers, a multimeter, a stopwatch, a sound level meter, and so on. Next, we will explain the testing standards and operational procedures for each segment, categorized by system. 1. Water source commissioning. Verify, in accordance with design requirements, the capacity of the high-level fire water tanks and fire water pools, and ensure that the installation height of the high-level tanks as well as the water level display of the pools, or tanks, comply with the design specifications. Additionally, shared pools or tanks used for fire water storage must have technical measures in place to prevent their use for any other purpose. Using a steel tape measure, determine the clear distance between the exterior wall of the pool, or tank, and the building structural wall, or any adjacent pool wall, as follows. For sides without piping, the clear distance should not be less than 0.7 meters. For sides where piping is installed, the clear distance should not be less than 1.0 meter. And the passage width between the outer wall of the piping and the building structural wall should not be less than 0.6 meter. Where the pool top is equipped with a manhole, the clear height between the pool's top slab and the underside of the overlying building slab should not be less than 0.8 meter. The clear distance between the bottom of the tank and the room's floor slab, when piping is present, should not be less than 0.8 meter. The water source system forms the foundation of the fire water supply. Only when its parameters meet the required standards can the stable operation of subsequent equipment be ensured. 2. Control cabinet functional verification. Next, we will perform a functional verification of the control cabinet. First, test the control functions of the control cabinet under no-load conditions and verify each control program through testing. After passing the no-load test, conduct load tests on the control cabinet's functions and verify the status of each load current through experimental measurement. The testing method is as follows. Connect the water pump to the load end, start the pump, and use a multimeter to measure the current in one of the phases of the pump's three-phase power cable. The control cabinet, which functions as the brain of the system, must operate normally as a prerequisite for the proper functioning of equipment such as the water pump and the booster pump. 3. Fire pump testing. Next, we will test the core equipment, the fire pump. First, close the water pump's outlet valve and open the test return water valve. Then, start the fire pump manually on-site and remotely from the fire control room. And observe the time it takes for the pump to reach normal operation. Whether started automatically or manually, the fire pump should reach normal operation within 55 seconds. When starting the fire pump via switching to a backup power source or a standby pump, it should reach normal operation within 1 minute or 2 minutes, respectively. The water pump is the dynamic core of the system. and its response speed directly affects the efficiency of fire suppression. 4. Booster pump commissioning. Next, we will commission the booster pump, which maintains stable system pressure. Adjust the booster pump start and stop functions by testing the electric contact pressure gauge. First, release water from the fire hose network to depressurize it. When the pressure within the network drops to the designed start pressure, the booster pump should start immediately. After starting, the booster pump should supplement the pressure in the network. And once the system pressure recovers to the designated stop pressure, the booster pump should automatically stop. The booster pump start and stop performance must meet the design pressure requirements, satisfy the system's automatic startup criteria, and cease operation when the main fire pump is activated, using a stopwatch for timing and observation. The number of start-stop cycles of the booster pump during normal operation should comply with the design requirements and must not exceed 15 cycles per hour, while maintaining system pressure under non-fire conditions. The reliability of the booster pump directly affects the coordinated performance between the alarm valve and the fire pump. 5. Alarm valve group testing. When commissioning the wet-type alarm valve, release water at the terminal device. The alarm valve should activate promptly when its inlet water pressure exceeds 0.14 megapascal and the water discharge flow is greater than 1 liter per second. Using a stopwatch, the hydraulic alarm bell equipped with a delay should sound within 5 to 90 seconds, while the one without a delay should sound within 15 seconds. Standing 3 meters away from the hydraulic alarm bell, its sound intensity measured with a sound level meter should not be lower than 70 decibels. Simultaneously, the pressure switch should activate promptly and initiate the fire pump. On the fire alarm panel and the integrated fire control system, feedback signals, such as the activation of the pressure switch, the water flow indicator, and the startup of the fire pump, should be observed. During commissioning of the dry-type alarm valve, open the system test valve. Then observe and record the alarm valve's activation time and the pressure at the activation point. Use a stopwatch to confirm that the time taken for the water to reach the outlet of the test device does not exceed 1 minute. All must comply with the design requirements. The alarm valve is the signal hub of the system, and its response speed directly affects the efficiency of fire suppression. 6. System integration, interlock, test. For the interlock test of the wet system, activate one sprinkler or release water at a flow rate of 0.94 liter per second to 1.5 liter per second at the terminal test device. Observe and confirm that the water flow indicator, the alarm valve, the pressure switch, the hydraulic alarm bell, and the fire pump all respond promptly and emit the corresponding signals. The interlock test is a key step in verifying the overall coordination of the system. 7. Fixed fire monitor, Canon, fire suppression system commissioning. When it is a manual fire suppression system, a water spray test should be conducted manually over the protected area of the fire monitor. When it is an automatic fire suppression system, water spray tests should be conducted over the protected area of the fire monitor using both manual and automatic control methods. During the test, record the time from when the startup signal is emitted until the fire monitor begins spraying water, ensuring that it does not exceed 5 minutes, and verify that all system performance indicators meet the design requirements. After all the above fire protection facilities have been commissioned, the commissioning record sheets must be completed and the test conclusions must be signed off as required. The commissioning and acceptance of fire protection equipment are directly related to public safety. Ensuring that the equipment functions properly is our professional duty. as well as a practice of the safety concept of prevention first, a combination of prevention and suppression. By following standardized operating procedures and a complete acceptance process, we not only demonstrate the professionalism of our technical work but also put our social responsibility into concrete practice.